Let's compute the critical value z of alpha over 2 that corresponds to a 94% level of confidence. So this question is asking you to do it using tables, but fortunately you can use StatCrunch to get the answer pretty quickly. So what I'm going to do is show you the StatCrunch way first because it's very fast, but then I'll talk about how you can use these tables at the end of the video. To start with, if you see this letter Z, we're talking about a z-score. That means we're using a normal distribution whose mean is 0 and standard deviation is 1. So in StatCrunch, let's start by opening that up. So I've opened StatCrunch, and I'm going to go to the normal calculator by going to Stat, selecting Calculators, and then choosing Normal. And so here it is, our normal calculator. And it's actually already set up so the mean is 0 and the standard deviation is 1. So this is perfect. This 94% means the following. If you go to the center, which in this case is 0, how far do you go away from the center so you've accumulated 94% of your data? Well, we're in the wrong mode because this is only going to the left or to the right. We want to switch it to the between mode. And the only other thing we need to do is, in place of the probability, since we're given 94%, I'm going to put 0.94 here. And I'll click Compute, and the calculator does the rest of the work for me. If you start at the middle, and you want to go an equal amount in both directions and accumulate 94% of the data, these would be the two z-scores that do that for you. Notice that 1 is just the negative of the other because you're going an equal distance in both directions. The value that we should put here is going to be the positive solution. So in this case, if we're rounding to 2 decimal places, that is 1.88. So that's it. Using StatCrunch, there is no other work to do other than to click here. I'll put 1.88, and that's the correct answer. So if you're fine with that, great. But if you want to know what the tables are all about, it's worth talking about that too. Okay, to start with, I need to talk a little bit more about what this notation is. Like, what is this alpha and divided by 2? So to start with, if this red part represents 94% of your data, well then the white part over here and over here, like this piece and this piece, are equal in size, but I know if we were to add those two together, that's going to be 6% of the data, because 6% plus 94% gives you a total of 100% of the data. If you want to know just one of these parts, like how much space does just this part take up, well, if they both take up 6%, you would divide it by 2 to figure out that, okay, this side is 3% of the data, and so is this side. And if you needed to, the procedure on a calculator is really simple. You would use 1 for 100% of the data. You'd subtract off 0.94, which is subtracting away 94% of the data. And this 0.06 is the sum of this part and this part. The divided by 2 is just telling you to take that area, divide it by 2, to get that, okay, this side by itself is 3%, and this side by itself is 3%. So in this problem, alpha by itself is 0.03 or 3%. That number is important when using these tables to figure out this value for z of alpha over 2. So I'll close the StatCrunch thing, and we're going to keep this 3% in mind, and I'll remove it from the screen as well. So I'm going to open up, I'll start with this first page, page 1 of this distribution table. Okay, and what you see is, all right, we have a bell-shaped curve, and it's a normal distribution. It's a standard normal distribution. The mean is 0 and the standard deviation is 1. What we want to do is find the z-score that corresponds to an area of 3%. So the area that is here should match up with that alpha that we found. And if you look at all these numbers, like what are all of these values? The numbers here in the center represent probabilities. So somewhere within here, we have to locate 3%. And then when we find it on this table, we're going to use it to figure out the corresponding z-score by using this column and this row. So it takes a while to locate it, but I'm looking for 3%. So like, here's 0.02, that's, about 2%. 3% is, okay, it's like right about, okay, here it is. It's not going to be perfect, but it looks like this spot right here is the closest to 3%. This is 0.0301. Okay, to construct your z-score, you look over, and we get this negative 1.8. Notice that the 1.8s match. Okay, that's how you get the first two values. But then to get the final decimal point, you then look up, and it's saying tack on an 8 to the very end. So like we had this 1.8, and at the very end we put on another 8, and we get this 1.88. Of course, I know we're really talking about, well, there's a value on the other side. It's just the positive of this number. So what we do is we make it a positive 1.88 instead of a negative 1.88. So that's what it means to use these tables to figure out this value. Step one is they'd give you the level of confidence. You would then do a little bit of work to figure out what alpha is equal to. You then would open up this table and somewhere locate alpha within here, and then look over and up to determine what the corresponding critical value is.